Welcome to my new video. Our today's question is adjacent increasing subarray detection 2. So it is the second part. Okay, this is the first part, adjacent increasing subarray detection 1, and it is, I think, more easier than the first part. Why? To think, to intuition. Okay, so you are given a nums array integer n. Okay, you are tasked to find the maximum value of k, and how and what is the k. Like if k value is 3, then you have to find the two subarrays of size k, and they should adjacent and also strictly increasing. Let me show you example. If the k is 3, so 7, 8, 9 is the first subarray of size 3, also strictly increasing, and you need to find second subarray, that is 2, 3, 4, which is also strictly increasing and adjacent to the first subarray. Okay, so you have to find the maximum k value. So let's start the question. Okay, I think the question is kind of easy. So what you need to find? So you have to find the two subarrays. Okay, like let's see. So first subarray and second subarray. So let me take the current. Okay, this is current and this is previous. Okay, so this is the length. Okay, this is the length. So current denotes the current length of the current subarray, and previous denotes the length of the previous subarray, and then we can easily calculate what our k value should be. Okay, so now just I am going to do the dry run. You are going to understand very easily. Okay, now what's the current? So 2, yes, we can take 2, then 5. 5 is greater than 2, yes, right? So we can take, like, 5 is greater than 2, so our length is 5. Okay, so we have to calculate first strictly increasing subarray. Okay, then we can easily calculate what's the our value of k. So I am going to take our k value here. So k value for now is 0. Okay, let's take, now we have to find the subarray which is strictly increasing. Okay, we have to find two subarrays and which is strictly increasing and also adjacent. Okay, so let's take 2. Okay, 2 is valid. Okay, now let's see 5. Can we take 5? Yes, 5 is greater than 2, so we can easily take. Okay, now our length is 2. Okay, now 7 is also greater than 5. Okay, so our length becomes 3. Now 8 is also greater than 5, right? 8 is also greater than 5, so our current length becomes 4. Okay, so if our current subarray, okay, if our current subarray size is 4, what's our k size? K can be, it's very simple, it's 2. It's 2. How? Like 2, 5, 7, 8, right? So we can easily divide into two parts, okay, of equal length. Okay, so this is the first subarray, this is the second subarray of size 2, and they are strictly increasing and also they are adjacent to each other. So our k is going to be 2. Okay, so k is 2. Okay, now let's move on. Can 9 is greater than 8 also, so our subarray is going to be this. Okay, so what should be our k value is also size divided by 2. We can divide this into two separate parts. Okay, like this is the first subarray and this is the second subarray, but our k value is, we want our k to be same. Okay, so we can easily take last two elements and first two elements. Okay, so our k is going to be same, right? Now our current length is 6. Okay, or not 6, sorry, 5. The current length is 5. Okay, like this is our subarray which is strictly increasing. Now let's see, can our 2 is not greater than, right? So 2 is not greater than 9, so we can simply stop. Okay, now we can simply store our current subarray length. Why? If when we dry run further, you will going to understand. Okay, so previous subarray length is 5. Okay, which is strictly increasing, so we have to find two subarrays. So this is previous, now we can again start to compute. Okay, now 2, we can easily take 2. Okay, we can easily take 2 because it's the first element. Okay, now 3 is greater than 2, so our length become 2. Okay, so our length become 2. Okay, now 4, can 4 is greater than 3? Yes, 4 is also greater than 3, so our length is 3 now. Okay, now let me tell. Okay, can 3 is greater than 4? No, so our subarray breaks. Okay, so now our current subarray length is this. Okay, 3. Now let me show you. Okay, if our current subarray length is 3, what should be the k value, like 2 3 4. The k value is very simple, 3 divided by 2 means we can divide it here. So our two subarrays are this and this, and we already, like, k value is going to 1. Okay, so we already have the largest answer. Okay, now let me tell you one thing. Okay, now we have two subarrays, current subarray and previous subarray. Okay, both are strictly increasing. So what should be our k value? Minimum of both. Why minimum of both? Like 3. Our k value should be, like, k value can be 3. How? So the the last three elements of previous subarray is strictly increasing and current subarray. So okay, so we have two subarrays. So this is the first subarray and this is the second subarray. Okay, so we can simply calculate. This is, okay, minimum is 3, so our k value is 3. Okay, this is the first three elements and the last three elements. Okay, so our k value should be 3. Okay, now, so what we have to do when we are traversing our current? Okay, so we have to just find the continuous increasing subarray. So our first continuous increasing subarray is 3. So but this is our first subarray, we want to find two subarrays, right? So but still, from our current increasing subarray, can we find two subarrays? Very simple, yes, we can simply divide here. Okay, the first subarray is this, second subarray is this. Okay, now when it's break means 2 is not greater than 9. Okay, so it's break, so we can again calculate. So our like, this is our current subarray and now this becomes our previous subarray, right? So if this is the previous, this is the current, what should be our k value? Minimum of both, right? Because both are increasing and adjacent to each other, so we can take the first three values and we can take the last three values of previous subarray. Okay, I hope you understand. So we can simply return 3. Okay, after that, okay, now again we can see. Okay, now our, let's dry run complete. Okay, now our previous become current. Okay, so 3. Okay, and our current becomes 1. Okay, right? Because we can say if there is one element, it's always going to be strictly increasing. Okay, now let's dry run. Okay, so this is our previous, right? Now our current is 3. Okay, 3, yes. Okay, 1 is not greater than 3. No, it is not greater than 3. So this is our current. Okay, this is our current value. Okay, this is our current value and current value. So what should be the k value? Minimum of both, that is 1. So 4 and 3, yes, both are, like, 1 is always going to be answer. Okay, so we have to take, we already have the better answer, so we are not going to do anything. So now this becomes our previous and this becomes our current. Okay, so I hope you understand. Okay, at the end we can return our k value. Okay, so now let's code this solution. Okay, so first take the n is nums dot size. After that we can simply take our current length is 1. Okay, because one length, any subarray of size 1 is always going to be strictly increasing. Okay, and now we have to take previous length is also 0. Okay, previous length is 0. Now we can simply traverse. Okay, we have to check for the strictly increasing subarray. Okay, so we are going to start from index 1. Okay, so we are going to start from index 1 because we already take our current length to be 1. Okay, so we already included first element, right? So we are now going from second element. Okay, I less than n, so I plus plus. Now we have to check if nums dot get I current element, if it is greater than nums dot get I minus 1. Okay, so that's why we also take, like, we have to compare to the previous element. Okay, so that's why we also take the I is equal to 1. That is the second reason. Okay, so because otherwise it is going to be out of bound. Okay, so we are comparing strictly increasing, so we can simply current length plus plus, so our current length going to be increasing, like, until, like, 2 5 7 8 9. Okay, otherwise what we need to do, we need to reinitialize. Okay, like, whenever, like, 2 is not greater than 9. Okay, so we have to reinitialize, like, this is the current. Okay, so it becomes previous, right? So our current, sorry, our previous length becomes current length. Okay, current length, right? So this becomes our previous length, right? Now our currents become 1. Current length becomes 1, right? Now after that we have to check what's our potential k. So our potential k will be uh, what is our current length? Current length, let's see for this in example, I is equal to 3. Our uh, current length is 4. Okay, so our current length is 4. So the potential k value is divided by 2. Okay, so current length divided by 2. Why I'm saying potential? Because if we already got the k value greater, okay, like in this case our value k value is already greater. Okay, so we are not updating every time, we are only updating when we got the k value greater than our current k. Okay, so now let's check. Okay, so we can simply update our answer. Okay, we have to first take our k value. Okay, k value should be 0. Okay, so we can simply say k is equal to math dot maximum of k and potential k. Okay, and next time it's going to update like we have our current subarray length is 3 and previous subarray length is 5. Okay, so we can simply take the minimum of both. Okay, so k is going to be math dot maximum of k and minimum of. So for simplicity I'm going to take, okay, what's our potential k? Our potential k is math dot minimum of our current length and previous length. Okay, so this can be our potential k. Okay, so we can simply update math dot maximum of k and potential k, right? And at the end we can simply return our k. Okay, so let me explain this line. I think you understand, but still, okay, for current length, previous length is 5 and current length is 3. Okay, when we are on index this, okay, our like sorry on this index. Okay, on this index our current length is our sorry previous length is this is our previous subarray and this is our current subarray. Okay, so what's the length of our current subarray is 3. Okay, and previous subarray length is 5. Okay, so we can simply take minimum of both. Okay, why? So if we take minimum, this is the first 3 element, this is the last 3 elements, they are strictly increasing, they are adjacent, right? And the size is also k. So okay, so we can't take the 5 size because the k value of both subarray has to be equal, so we can take last 3 elements, right? Right, so now let's run this code. Okay, just a second. So now let's try to run this code. Okay, okay, what's happening? Okay, current length. Okay, so this is greater. Now let's try to run this. Yeah, it is running. Let's try to submit it. Okay, yeah, it get accepted. Thank you so much for watching, and if you have any doubt, make sure to comment. Okay, if you are new to the channel, make sure to like, share and subscribe.